So let me first define the node voltage to be Vx. I will define 3 outgoing currents as there are 3 branches. Please remember that this will not become a node because this is an open circuit, and because it's an open circuit, there is no current flowing through this branch. So this 10 ohm and this 5 ohm resistors, they are in series. So this cannot be defined as a node. And hence there is only one node, and when I define current through this 10 ohm resistance flowing towards right, this current will also keep flowing through 5 ohm resistance and through this battery towards the ground. So there is no this branch, and as of now please ignore VTH for a moment when we write KCL at node Vx. So let's write down, so that's the second particular point in this solution. So write KCL at node Vx. This current will be nothing but Vx on one side and 2 volts on the other side. So Vx minus 2 divided by 5 plus next will be Vx upon 10. Vx by 10, that's the current in the vertical branch, plus current in this whole branch will be Vx. There's a voltage source here. So like we had written Vx minus 2 upon 5, it will be Vx minus 5 divided by, now see these two resistors are in series, so the total resistance will be 10 plus 5, that will be 15, and this will be equal to 0. Let's find out Vx from this first. The LCM will be 15, so the first term should be multiplied by 3, so that will become 3Vx minus 6 plus LCM will be 30, so let's multiply the first term by 6 because we already have find the denominator, so you get 6Vx minus 12 plus here it will be 3Vx because this time there is 10 in the denominator, and because there's a 15 here we'll multiply by 2, so it will be 2Vx minus 10 equal to 0. So total Vx on this side will be 6 plus 5, that's 11Vx, and on the right hand side minus 12 and minus 10 goes on the right hand side will become 22. Now this gives me the value of Vx, which is 22 by 11, that will be 2 volt. Now once I got the value of Vx, I can find out this particular current. Let me call this current as Ix. Current Ix is flowing through this 10 and 5 ohm resistance through 5 volts battery towards the ground. We have already used this current in writing the KCL at node Vx. So what will be the value of Ix? Ix will be nothing but it is Vx on this side and 5 volts on this side, so it's Vx minus 5 divided by the total resistance, which is 15. Now Vx is only 2 volts, so it's 2 minus 5 upon 15, which is minus 3 by 15, and therefore Ix with its right hand side direction comes out to be a negative current. It's minus 3 by 15, which is minus 1 by 15, which is 0.2 amperes. So that's my next value, Ix. Now you must be wondering why we have found Ix whereas our main aim is to find VTH. That's simply because now if you see, when I find out the value of VTH, let us see what is going to be VTH. To find any voltage, you will have to always travel from its negative polarity to its positive polarity, and when you travel from negative to positive polarity, you'll have to go on collecting all the voltages that you come across. I repeat, to find any potential difference between 2 points, we start from its negative polarity, travel to its positive polarity, and go on collecting all the voltages in the path. You can go through any path you want, the voltage difference will not change. We do not travel through a path which contains a current source, because if you remember, we had seen this before, you can't define the voltage across current source in KVL equation. Whenever there are multiple paths available, we always choose shorter paths so that we have to add lesser number of voltages.